Hey pre-calc classes, hope you're all hanging in there. It's been a crazy week for me trying to prep all of this stuff. Hopefully these remote classes will be of some help and these videos will definitely be of some help, I'm sure. Okay, so now I'm approaching Thursday's lesson. This is a very big lesson. I'm going to definitely have to break my videos out. I made one the other day, it was so long YouTube wouldn't post it, so I'm going to have to chop them up and watch my time. Okay, first of all, since I'm teaching remotely, I'm going to have to do away with the ICE that used to be the in-class example acronym. I've come up with something else. It's probably as corny as you've seen, but I'm going to call it REX. Remote examples. So when I come up with an example that's not really in your assignment, I'm going to call it a REX. So you can track it and go, okay, REX number 1, REX number 2, or whatever. And now that we are remotely, I thought the R for remote would, make sense. All right, another thing you're going to need, and I have posted on, I think every day that we're doing Trig Identities, I have posted this. This should look very familiar to you. You're going to need this. This will be your right-hand resource for what we're about to do. We're going to be verifying Trig Identities, and you're going to be involving all of these at some point, okay? Probably not so much this one, because this is more reserved for the unit circle and finding X, Y, and R. But the rest of them, and you won't need arc length or arc sector, but you're going to see what I mean once we get into these. I'm going to start pretty basic today, but what we're essentially doing is we are going to be proving or verifying trigonometric identities. Okay, so again, remember, I need to move kind of quickly, so you can always pause it or come back to it. But before we get started, there's some skills I need to make sure you know how to do, okay? Otherwise, you're going to be throwing me curveballs, and it's going to be a hot mess when you start doing these trig identities. Okay, so one of the things that I need to make certain that everyone in these classes knows how to do, all right? It sounds kind of elementary, but still, I can remember bringing this up in class and people going, what in the world is that? I've never seen that. All right, so commit this to your memory banks. All right, to combine unlike denominator fractions, okay? They're going to be separated by either addition or subtraction. Okay, in the middle. So here's the deal. I started with the fraction sine of theta over tangent theta, fraction number 1. Add to that fraction number 2, cosine of theta over the denominator 1 plus cosine of theta. All right, so I'm adding these, so I'm combining. These are unlike denominators. The first thing that you're going to do is you're going to know you have to multiply these two denominators to get your new denominator. So I simply put tangent smack up against 1 plus cosine, indicating multiplication. All right, because we've done that, we need to adjust our new numerator. Very simply, you are going to cross multiply left diagonal down to right, bottom right. That's sine times 1 plus cosine theta. You can see my arrow here. I simply said sine of theta times 1 plus cosine of theta. All right, the symbol in between the operation is adding. Then you will do the left-hand other diagonal in the same fashion. So it will be cosine of theta times tangent of theta, and that will be here. This is your new and improved fraction, okay? I don't care what the fractions look like. When you have this, and you're going to have this a lot in identities, you've got to know how to do this, all right? 2 other skills you're going to need to know. So please make sure you take notes on this or come back and review these pages. All right, there's something that's called decomposing fractions, and I'm looking at this top part above this squiggle. Okay, decomposing. All right, so let's say you've got a fraction and it has a numerator. Let's say it looks like this, and it's got a denominator where these two are multiplied together. Well, it is perfectly legitimate to separate one portion of the numerator, use your addition sign, and take the other portion of the numerator and place it over the same denominator. So you're just splitting them apart. So this would be the first part of your decomposition, tangent of theta over sine theta cosine theta, plus, because there's a plus, and now 2, this numerator remains over the same denominator. Because if you were to go backwards and add these two together, you would know the common denominator wouldn't change. It would still be sine cosine, but these two would be brought together as a numerator. So we just went in the reverse and we decomposed it. All right, there's another type of decomposition. Okay, another type of decomposition. Let's just say, forget the 1 for a second. Let's say that your fraction is sine of theta over cosecant of theta times secant of theta. Okay, so let's just say that, all right, I know invisibly there's a 1 here. Okay, so I can separate these, and this is multiplication. So you can absolutely just separate them out. This would become one fraction multiplied by a second fraction. So decomposition of a product or multiplication is simple. Sine of theta over cosecant of theta is one of your fractions times 1 over secant of theta. You multiply these two together, you'll get this back again. Sine of theta times 1 gives you sine of theta. Cosecant times secant gives you cosecant secant here. Okay, so these are the skills that you're going to need to make these verifying identities to make it happen. Okay, so what does that mean when you're verifying an identity? What that means is this. Verifying trig identities. This is level 1 that we're doing today. These are going to get more and more challenging. Okay, this is probably one of the most challenging things in trig that we're going to do. I know you don't want to hear that, but I got to be straight up honest with you. All right, we're starting with level 1. Okay, what does it mean? What are we doing? How do we verify it? Okay, you are going to use your trig identities, which is on your formula sheet. Okay, so that's going to come from your formula sheet or your memory. Okay, to transform one side of an equal sign into the other. Okay, you're going to use your identity sheet to help you do that. Pretty soon you won't have to rely on that. Okay, so we are basically taking the left side or the right side and making it equal to the other side. All right, so you will never work both sides at the same time. So here's some rules on how to verify identities. These are some steps. Okay, number 1, work only one side, work only on one side at a time. You will never use left and right sides together, bringing them down. So you'll either use the left or the right. It depends, okay? Typically it's the left, but it may differ. All right, number 2, here's the deal breaker as to whether you're going to use left or right. Sometimes the left and the right sides look to be the same degree of complexity, so you could pick either one. Start with the more complex side, okay? That means that one's a little beefier, it's got a little more to it, maybe a little more layers, a little more fractions, okay? And reduce it to match the simple side. It is so much easier to start with a complicated side and break it down to an easy side than to take an easy side and build it up to a complicated side. Trust me on this. Step 3, note which of the functions are in the final expression. So let's say you start on the left. Look at the right-hand side of the equal sign and see what expressions are there. Is it full of sine and cosine? Is it cosecant? Is it tangent? What is it full of? Okay, and use the identities on your identity sheet to make the proper substitutions to the left-hand side. Okay, and eventually you're going to work your way down to where you match the right side. That's the name of the game. All right, now to the next page. So again, work only on one side at a time, left or right. Preferably, more often than not, you're going to use the left. But that's not written in stone. Start with the more complex side, whatever it is, and reduce to match the simple side. If the sides are equivalent in complexity, just pick a side. Okay, note which functions are in the final expression. So let's say you pick the left side, you're going to look at the right side and say, okay, what functions are in that expression, and that's where I'm aiming to hit. My left side, I've got to change it and tweak it and morph it so it ends up looking like the right side. Okay, the last step. Okay, when all else fails, put the more complex side into terms of sine and cosine only. This is because all of the identities, as we mentioned 100 times before, are all based on sine and cosine. So when all else fails, now you may have more steps, okay, and more decomposition of fractions or whatever, but that's okay. All right, so I want to start with those steps and make sure you get that down. So step 4, when all else fails, put the more complex side into terms of sine and cosine only. This is because all our identities are tied back to or based upon sine and cosine. All right, so I'm going to stop the video here, and then I'm going to reconnect with part 2, and we might need a part 3 for this day. This is a lot. I'll be back in just a second.